All right, let's take a look at problem number one. Find the intercepts. Okay, so remember on intercepts, we're looking at places where the y is 0 and places where the x is 0. Okay, so let's take this function and substitute 0 in for x. So let's see, y is equal to 0 minus 1 over 0 plus 3. Y is equal to negative 1/3. So that's one intercept right there. We know 0 comma negative 1/3. Okay. Now remember, to find the other intercept, we have to find where y is 0. So I'm going to put 0 in for y in the function. Now, there are 5 ways to explain this. The easiest way is to consider 0 as 0 over 1 and cross multiply. X minus 1 times 1 is x minus 1. X plus 3 times 0 is 0. And here we have x equal to 1. Another way to understand that is if I put a 1 in for the numerator, I have a 0. Okay, so we probably understand that a little bit better now. Now, how are we going to write the intercept? 1 comma 0. So there are 2 answers there for that problem. So that's answer choice A. Okay. Now, question 2 says, I want to know if this function that I'm looking at right here is symmetric. Is it symmetric? Well, the question that we're looking at here, hold the phone. Okay, so question says, determine if the graph is symmetric with the following. All right, now we need to review this for a second. Symmetric with the x-axis is this way. That's the graph of x is equal to y squared. Symmetric with the y-axis is this way. Okay, and that's the graph y equals x squared. And symmetric with the origin, a good example of that would be the cubic function. Y equals x cubed. Okay, so is it symmetric with these? Well, the first thing to do is look at the function and notice that there's 2 x squareds there. So y is equal to x squared over x squared minus 4. If you put this in your calculator, you would see that symmetric with the y-axis. But all you have to do is realize if you put a 2 in for x, or you put a negative 2 in for x, they're both going to give you the same y. And that is this case right here. Okay, right? If I put a negative 1 in for it and square it, or a 1 in there and square it, then that is an even function or symmetric with the y-axis. So the answer, because there's a squared, is symmetric with the y-axis. So y-axis. And in that particular case, it's answer choice B. 3. Here we have this equation. Let's see. We have x squared plus 3x minus 3 is equal to y. And then we have this other equation, y is equal to, well, if I solve this and move this x to the other side, it's negative x plus 2. Okay, and again, what I did in the first equation, I moved that y to the right and moved that 3 to the left. The question really is, could I graph this line and this quadratic? That's really what the question is. All right, so a little sketch, having done that on the graphing calculator, okay? So here's the x and the y-axis. the parabola looks like this, and the line looks like this. Now you could use your trace key and then just hit the number 1, and if you do that, you will get in this location right here, so you know 1 comma 1 is a point. And then you're trying to find this other point over here. And the way to do that is take a guess on your calculator and try -5. If you hit -5, you could find that common point as well. So -5, comma 7, you could read that off your calculator. Another thing you could do on your calculator, there actually is a function where you can find where two functions intersect. You could ask me in class and I'll show you how to do that. So the answer choice for that problem is D. Question 4, what is the graph of that particular function? Okay. Well, we know it's a cubic. Cubics look like this, but there's a -1 on the inside. Whenever there's a number on the inside, it moves it right or left. So what we're looking at here is a cubic moved to the 1 unit to the right. So we're looking for a graph that looks like this, which if you look at your answer choices, that is answer C. Okay, so we're looking at question number 5 right now. Question 5. Okay, find an equation for the line passing through the point and the line. As soon as you hear find the equation of a line, I normally write that. I'm more of that form of a linear equation person. Don't forget we have a point right here and then parallel to the line this. So we know that the point, okay, so 4 comma -1, we're going to use that information. Now we have to find the slope. The way to find the slope is to just take the equation of the line, okay, now obviously we got to solve for y, so we're going to divide everybody by -3. This is my little shortcut lingo for that. So y is equal to 2/3x minus 1. Really, all I care about on this line is the slope, 2/3. So now I know the slope over here is 2/3. All right, so write an equation. Well, y equals 2/3x plus b. Remember, we're going to put the -1 in for y and the 4 in for x. Okay, plus b. All right, so -1 is equal to plus 8/3 plus b. We got to subtract 8/3. So on the left side, I have a -3/3 minus 8/3, and that's going to be b. Now we know that is -11/3. Okay, so if we put that back into our original function right here, okay, right, we're trying to find linear equation. Y is equal to 2/3x minus 11/3. Well, we look at the answer choices and they're all in standard form. So we're going to have to multiply this equation right here by 3. That would be 3y is equal to 2x minus 11. Now we look again and realize that this is not in standard form yet. How about we move the 3y over here and the 11 over there? So 2x, right, minus 3y, right, is equal to 11. Okay? We look at our answer choices for that, and that is answer choice A. That's how you do problem 5. Okay, folks, let's look at question number 6. The question says, find the domain of the function. Okay? Find the domain of the function. Now remember, from your previous work, in algebraic functions, you can't have a 0 at the bottom, and you can't have a negative inside the radical. So in this case, we have a denominator and a radical, which means that 3 plus 2x, okay, not only can it not be negative, which means it has to be greater than 0, okay, but it can't be 0 because that would cause a 0 on the bottom. Let's solve this. 2x is greater than or equal to negative 3. X is greater than or equal to negative 3 halves. In our previous knowledge, we knew to graph this as a what? As a, now wait a minute, it can't equal 0, so it's got to be just greater than 0. Let's knock that off. Okay, what is that? That's an open circle and an arrow going what? That way. Now, in interval notation, open circle means parentheses, closed circles mean brackets. So since the negative 2/3 is not included, everything to the right of that. Okay, that's called interval notation. So the answer choice for that problem would be C. Now I gave you some partial credit if you mistakenly understood, pick that, then I just took off 1 point. Keep that in mind. Okay, here's the question. Find f of x plus delta x for this function. Now remember, okay, where we have a function box, right? And inside that we have x squared minus 2x minus 3. And what are we going to do? We're going to plug in x plus delta x in for the x in the function box. Now, so we have the function says something squared plus 2 times something minus 3. Well, what are we going to put in for there? We're going to put in there the value or expression Okay, now I mentioned the first day how to do a binomial squared. You square the first, you multiply them together and double, and then you square the last. I just tend to leave off the parentheses and treat delta x as the variable it is. Plus 2x plus 2 delta x minus 3. Okay, and if you look at your answer choices, that is answer choice B. Okay, find fog. Remember, fog of x. What is that? That's really f of g of x. Which means go to the f function, which is 1 minus something squared. What am I going to put in for that something? I'm going to put g, which is what? 1 over radical x squared. So let's simplify this. 1 minus, what is 1 squared? 1. What is radical x squared? That's just x. That's really all that's involved in that problem. That is answer choice C.